Hello everyone. I wanted to do a quick recording on how to use a solubility table to predict whether something is soluble or insoluble. Now I like a table like this because it gives you general rules. There are other types of tables that are a little bit more definitive, but this is it's good to know that, for example, most nitrates are soluble, most halides are soluble, most sulfates are soluble. So this grouping at the top, okay, all the way down to here, these are generally soluble compounds. Now, again, we're looking at salts, so there's a cation and an anion. So if it says something with sodium ion is generally soluble, all right, well, that would be sodium with some other anion, like chloride, okay? Or, maybe with something like nitrate, or maybe like something like hydroxide. Okay? So we don't have to list both cation and anion. If it contains an alkali metal, those salts are generally soluble. If it contains the nitrate ion, those salts are generally soluble. If it contains the chloride ion, those salts are generally soluble, and so on. Okay? So you need to know how to use this table. It's very helpful. Now, there are some exceptions. So to the soluble compounds, the exceptions would be insoluble. So let's look at some of these exceptions. So chlorides are generally soluble, but if it's Ag plus with Cl minus, that's an insoluble exception. So this would precipitate from solution, come out as a solid, would be it'd be considered insoluble in water. Now remember, even insoluble means very slightly soluble, but for our purposes, we're just going to classify soluble or insoluble. Okay? So certainly silver chloride would be an insoluble compound. Same thing for lead, 2+ with chloride. And so since lead has a 2+ charge with chloride, we would need 2 chlorides. That would be an insoluble salt in water. It would not dissolve to any great extent. Okay? Now you can go through the same thing with sulfates. Sulfates are generally soluble. But there are some sulfates that are insoluble. So if silver ion is combined with sulfate, insoluble. Calcium sulfate, strontium sulfate, and so on. Okay? Now, let's go down to the bottom of the table. And this is why I like this table, because it gives you a feel for what types of compounds are generally soluble and what types of compounds are generally insoluble. Again, we're looking at ionic compounds, salts. All right? So, what are generally insoluble? Salts that contain carbonate are generally insoluble. Salts that contain phosphate, chromate, sulfide, and hydroxide. All of those are most often insoluble. Okay? So something like iron, this is called iron 2 sulfide, FeS. Sulfides are generally insoluble, so this will precipitate from solution as a solid if we're looking at precipitation reaction. But we'd classify iron 2 sulfide as an insoluble compound. Okay? Same thing for hydroxides, like a copper 2 hydroxide compound. Okay? Most hydroxides are insoluble, so this would be insoluble as well. Okay? So again, bottom of the table, most carbonates, most phosphates, most chromates, sulfides, hydroxides, most of those are insoluble. And again, that's just the anion part of the salt. There will be a cation. For example, we have Fe2+ with sulfide here. We have copper 2+ with hydroxide here. Okay, so those salts, insoluble. Now, there are some exceptions. So under the insoluble compounds, the exceptions would be soluble exceptions. Now, this shouldn't surprise you. Well, if it's one of these anions with an alkali metal, look back up here. Alkali metal compounds are generally soluble. So if we had sodium, and again, sodium's +1, when it reacts, it's going to lose 1 electron, with carbonate, -2, this would be a soluble salt. All right? Carbonates are generally insoluble, but if it's combined with one of the alkali metals, it is soluble. Also with the ammonium ion. If it's combined with the ammonium ion, it would be soluble as well, carbonates or phosphates, sulfides, and so on. Okay? Hydroxides are almost the same. Hydroxides have a little bit different story than these other anions. Again, combine, sorry, I kind of drew a line through there, but alkali metal hydroxides would be soluble. Okay, and I've kind of run out of line. Let me scroll down just a little bit here. So something like sodium hydroxide, soluble. Okay, cesium hydroxide. Okay, alkaline metal hydroxides are soluble. Okay, also barium hydroxide. So barium is 2+, hydroxides -1, so we're going to need 2 hydroxides. That would be soluble. All other hydroxides, other than alkali metal hydroxides and barium hydroxide, are insoluble. Okay? So pick any other hydroxide, like we did up here. Copper is not an alkali metal or barium, so that would be an insoluble hydroxide. Okay? We could do the same thing with iron. Iron hydroxide. It's not an alkali metal or barium. This would be insoluble. Okay? So make sure you can use this table to figure out solubility. Okay? Because this is kind of the first step as we get into writing reactions, writing precipitation reactions. You have to be able to decide whether one of your products will precipitate from solution, and you're going to use this table to do so. All right. Hopefully that helps. We will do more of this in class, give you more practices with material, and eventually we're going to use this table to write out complete precipitation reactions. But again, the first step, you've got to identify soluble from insoluble to start, and then we'll go from there. All right, I will see you soon. Take care.